Hey, welcome to Doozer shop. Doing some work on the Hendey tailstock. Spindle, quill, ram, different names for it. I guess I call it a quill for the tailstock. Previously, I had bored it out in the middle with a 9/16 really long drill bit. Had it over on the surface plate, checking it for straightness and roundness, and it's tri-lobed by about between 2 and 4/10. Two of the high spots, two of the lobes are about 2/10 high, and one lobe of the tri-lobe is about 4/10 high. And Brian Block had a good suggestion of making an OD lap to get some of that tri-lobe out of there, maybe out of aluminum, a split lap. Thanks, Brian. I probably will do that. That's a great idea. But hedging my bets, what I'm going to do now is mill the Keyway, the whole length of that 19-inch bar. And I set it up on the Bridgeport. I'll show you in a second. And I put the highest lobe of the tri-lobe, and as a sidebar, tri-lobe comes from centerless grinding, right? Where there's a main grinding wheel and a regulator wheel, and the workpiece is in the middle. And if you don't set it up right, it starts lobing. A couple tenths is not bad, but that's what I got. So less talking, more showing. Let's go to the Bridgeport, show you what I got. Right? We love it. Go on Walkabout like Crocodile Dundee, right? That was a great movie. That's probably 20 years old, that movie. All right, here we go on the Bridgeport. I took off the Curtis vise, and luckily it's not too heavy. So the overall shot is I got it on the Bridgeport table and I put it in one of the T-slots, and I ended up putting it in the back slot because I had the least amount of nicks. And I filed some of the nicks off the edge of the T-slot, and normally you don't get into that with mounting something flat on the table like a vise or whatever, because it just sits on top. But because we're using the T-slots and the edges, and you know, things get knocked around and whatever. So I cleaned that up the best that I could, and show you what I got here. So I got it clamped with these things, right? These are they're strap clamps. I guess I call them strap clamps or table clamps. The U kind. Ooh, tuning fork. All right, that's fun. So they got a little dog coming out the side, a little proboscis. And what that's for, if you guys didn't know, is if you got a workpiece with a hole in it, or drill a hole in it if it's a sacrificial end of the stock, and put it in there and you can hold it down. So that's what I did. This is just a 1/4-inch shim on that side, and same here, I got just a 1/4-inch shim on this side. And man, I got a whole bunch of these nice beefy top hat washers. And these are actually the bolts for the vise, from holding down the vise. And I got a magic marker line here, and I had this in the V-blocks. That's the most pronounced lobe of the tri-lobe. So anyhow, I'm going to do some edge finding here. I wonder how this works, if I can just... Yeah, maybe I can just do that. So what this is I made this, it's kind of an edge finder. It's a ball bearing on a 1/4-inch rather long dowel pin, right? And I'm putting some magic marker lines, and it's great as an edge finder if it's a little bit longer. You know, the regular edge finders are so darn short, right? They're just so not long. the longest you can put on, you know, get a long dowel pin, the sky's your limit. So what I'm going to do is I'm going to go right down to approximately the center, and when this thing touches, it'll stop spinning. Actually, it'll skip because there's a couple tenths of eccentricity. But this is just a cool thing, and I think it's either press fit or Loctited on there a little. I forget what that is, an R4 bearing or something. It's not it's the small one. It's an R3. So let me show you here the dealio. All right, I'm going to creep in the table, the y-axis, just very so slowly. Almost touching. Come on. Oh, okay, see how that, it's just touching, it's skidded around and it stopped, it's kind of moving. So I'm going to zero my readout, come back off of it, let me come back in again. 6, 5, 4, 3, 2, 1. One thou away, and right I'm at 0. So I hope you can see that it's just skipping. If I go in just a touch more, it's completely stopped. That's half a thousandth. So I'm going to do that on the front, raise it up. I zeroed my readout. Do it on the back and divide by 2, and you know, I'm going to stop there because I don't think I can't get the camera around back. But you get the idea. I'm going to split the difference. So I'm going to cut a 3/16 keyway, and I'm not going to use a 3/16 end mill because they always drift from the rotation of the cutter. They always bend, and they cut oversize. I could probably stand to cut oversize on this because this is a running fit. It's just an anti-rotation feature for the tailstock coil here. But anyways, I'm going to get set up with a 5/32 end mill, which is 0.156 inches, which is 32nd undersize, 30 thousandths undersize. And I'm going to run about 2,000 RPM. Ooh, wow. I'm going to be buzzing that thing really fast. 2,500 is about where I want to be. I think the bearings get a little warm when I run it at full capacity. I'm going to run it at 1750 and put my earplugs in. So anyhow, that's my setup so far, and I'm going to get working on this, and I'll bring you back maybe some more Action Jackson here. Alright, you guys want to watch some milling? Alright, it's kind of boring, but I won't show you the whole thing. Just clean off the slot with my chip brush. Alright, give it a little oil, just a quick bit of oil. It's a 5/32 0.156 end mill. We're just slotting it down and going to widen it out. I'm going 15th thou per cut, 1750 RPM. It's going to be loud. I'm going to do one pass and then I'll just show you the finished result. So let's go. that was about 3 minutes, probably about 2.5 minutes if I subtract out all my time talking about it. But what am I at? 75,000. So I'm going to go to, well, it's a 3/16 keyway. Half a 3/16 for the depth is going to be 3/30 seconds. 3/30 seconds is 0.093 inches. And probably go to 0.95. And I'm at 0.75 now. Alright. Let's go one more back, and if you don't like it, you just fast forward and click through, right? Everybody, that's what they want to do. Alright. Contact. Did I go down? No, I didn't go down. There's 90. Alright, there we go. That's 6 minutes of glory. Maybe I'll edit that down, maybe I won't, I don't know. But anyhow, I'm at 90 thousandths deep. Now I gotta go a few more thousandths and, you know, widen it out. I am gonna take a measurement and see where I'm at. See how that 156 diameter end mill's cutting. And kind of judge my offsets from there. Alright, like I said, I could have done this on the planer. Not comfortable with the planer for doing a critical thing yet. Could have done this on the Kearney and Tracker horizontal mill and feel like setting it up, and I've not done anything on that yet. But I don't want to do, you know, a good part on it. I want to do some test stuff. Alright, I'll bring you back in a minute. Alright guys, got you back. I got finished with the shaft, with the keyway, and keyway looks great. I've got a 187 stack of gauge blocks is just a scooch loose, and 188 won't go in. So, and I could play with the 10th blocks if I wanted to, but the real pudding is the key that goes in the tailstock. It's got a little wear step in it, but if you put the good side in, fits right there. Of course, if you flip it over, the worn side is definitely going to fit. But I think I'll make a new one out of key stock, piece of key. But I'm happy with that. So, wasn't that hard, didn't take that long. Let me come down to the end here. Yeah, man. I know, very easy, very simple mill operation, but, you know, just, I don't know. I've been putting it off because I've been doing other stuff, but whatever. So that's, that's where I'm at. Done with that. Now let's see if it fits in the tailstock. Let's put on the surface plate on the V-blocks and see if it bent. Because when you relieve material, if there's stress in the material holding it straight and you take that material out, it's gonna bend. I had to bend these initially 5 thousandths over the length of them to straighten the bars. It shouldn't move. If it moves, or if it did move, I'll straighten it again. Because, you know, that's what having a shop is all about. Alright, let's check it out. Alright, very close to 0. So that's 0. So I'm rotating one direction. And the keyway is almost going to fall off the V-block. So that's about 1/10 below. Coming up, 0. Right at the edge. I'm a little high on the 0. Let me drop into no man's land. Let me come back out of no man's land. Alright, I'm still right around the 0. I'm falling off a couple tenths. And I'm right where the keyway is going to fall in the V-block. Now let me go 180. Let me go over the hump. Alright, now the keyway is exactly at the bottom of the V-blocks. Right? Okay, there it is. So I'm looking 5, 6, 7 tenths below 0. I'm 7 tenths below 0. About 7 tenths. Now let me keep going the same direction. The keyway will drop into the V-block edge. Alright, I'm over that. And now I'm 2 tenths below 0. And I'm at 0. So is this thing bent 7 tenths now? Because that keyway, let me go to the bottom. That's dead at the bottom. 6, 7 tenths. And let me zigzag side to side. Yep. Alright, there's 0. There's 0. 2 tenths over. 0. 2 tenths over. Keyway again. I'm within 2 or 3 over here. I don't think I can check it for if my V-blocks were exact. I got a better set of V-blocks somewhere, and then I can check it for bend. But so far I like what I'm seeing. This is getting a little long. I'm going to keep inspecting here and just see if this is straight and round, and I'm probably going to end up making an OD lap for this, like Brian Block suggested, which is a really good idea. Because this goes into the tailstock still, but just barely. So, alright, hope you enjoyed this little foray into making this, and it just shows that, man, when you're doing precision stuff, nothing fits together. You got to really sneak up and figure out and make things round and flat and straight and whatever. Alright, hope you enjoyed this. This was Doozer Shop.